Welcome to qnawire.
Here it is given a cylinder having frictionless movable piston like that contains a quantity of helium. So there is a frictionless movable piston in which helium is filled. The gas is at pressure, helium at pressure 1.0 into 10 to the power 5 Pascal, and has a temperature, that is initial temperature of the system is 300 Kelvin and occupying the volume of 1.50 liter. The gas is then undergo two processes. In first process, gas is heated and piston is allowed to move to keep the temperature equal to 300 Kelvin. That means the process is taking place at constant temperature and final pressure becomes 2.5 into 10 to the power 4 Pascal. And in second process, the gas is compressed at constant pressure. Compression at constant pressure so that final volume becomes equal to initial volume of 1.5 liter. In part A, we have to draw the PV diagram. In part B, find the volume of the gas and the first process. We at the end of first process. C part, find the total work done by the gas during both the process. Total work done we have to calculate. D. What we have to do to bring the system at initial pressure and temperature. So these are the few questions we have to discuss. First part, PV diagram. First process is isothermal expansion. And second process is compression at constant volume. So this is the first process. And this is the second process in which pressure is constant. So 1 to 2 isothermal, and 2 to 3 compression at constant pressure. Now, B part. Work done. Pressure into change in volume. Pressure can be written as force on the piston. Just a moment, please. In part B, we have to calculate temperature. So first we will find the volume at the end of first process. So first process is at constant temperature. For first process, temperature is constant. So at the end of first process, you can find the volume V2 is equal to V1 P1 upon P2 because temperature is constant. V1 is 1.5 liter. P1 is 1 into 10 to the power 5 Pascal and P2 is 2.5. So this becomes V2 becomes 6 liter. Now the final pressure is given P3 is equal to P2. Final volume is equal to initial volume. So T3 we can find final temperature, that is T1 into P3 upon P1. Not T3. In the beginning, temperature is given 300 Kelvin. P3 is 2.5 into 10 to the power 4 and P1 is 1 into 10 to the power 5. So on solving this temperature you will get 75 Kelvin. So final temperature is 75 Kelvin. Now C part of this problem. We have to calculate the total work done. So first process is at constant temperature, so it will be nRT ln of V2 upon V1 and that can be written as P1 V1 ln of P1 upon P2. Now substitute the value. So work done in first process we will get P1 is 10 to the power 5 Pascal, V1 is 1.5 liter but it has to be used in meter cube. P1 is 1 into 10 to the power 5 Pascal and P2 is 2.5 into 10 to the power 4 Pascal. So on solving, this work done will be 208 joule. Now work done in second process. Second process is taking place at constant constant pressure. So it will be P2 into V3 minus V2. P2 is 2.45 into 10 to the power 4. V3 is V3 is equal to V2. So V2 minus V1. So on solving it, this would be 113 joule. And this will be negative because it is finally compressing. So it will be negative. So total work done you will get W1 plus W2, 208 minus 113. So you will get 95 joule. This is the answer of C part. In D part, if we have to obtain, if we have to attain the original pressure and temperature, then heat must be supplied. Just a moment. To attain initial pressure and temperature, heat must be supplied at constant volume. Thanks for watching.